Hello everyone, welcome to my YouTube channel The Learning Hub. In today's lecture we are going to discuss about pumping lemma for regular sets. So let's first understand what does it mean by pumping lemma. Pumping lemma means generating something. It means here we can say when we talk of pumping lemma, it's nothing else, it's just generating new strings. So here it means by it is simply generating of something. And it may be creating new input strings from a given string. It can be used to show that certain sets are not regular. So basically it works in contradiction. When we talk of pumping lemma, it is basically talking of contradiction in this part. So here we say when we want to prove that certain sets are not regular, then we use pumping lemma. So let's firstly have a look at the tuples in the pumping lemma. First, basically pumping lemma is a machine which has five tuples just like finite automata, but it has n number of states. So here we say that if there is ln language which is present and it is accepting by a particular machine which has this five tuples, that is by a finite automata machine, this language is to be accepted, then we consider a substring w that belongs to this language. Now suppose we are having a language of consisting of these, and here we pick this string, so this is w which belongs to this particular language. So when we consider this, we say that this word is greater than equal to the length of this string is greater than total states, means the size of machine should be smaller than the string. And we consider a value n, so n is nothing else, n over here simply dates states, that is number of states in pumping lemma machine. So when we talk of pumping lemma, there are few applications of pumping lemma. So these applications are nothing else, they are just this is just used to prove that certain sets are not regular. The steps which we consider for this is, we assume a language L, as we have already discussed, which is regular, and we consider n value that represents the number of states in the corresponding finite automaton. So we choose a string w such that the string length of that string, the length is greater than equal to total number of states. So if we consider that the size of the machine is 5, then we consider a string which should be at least 5 or more than 5. So when we got this, we divide the pumping lemma string into x, y, z, three parts, and with these few conditions. So here we say, suppose we were having a language L, and from that language L we have taken a string w. Then here we say this w is divided into three parts. Those parts are x, y, and z. And while division, we have to consider a few conditions. So here we were talking of, we were having a language L in this, and from that language we pick w, which is nothing else, which is a string of this language, where w belongs to this language, and we have n that represents number of states in pumping lemma machine. And we will pick this w. We know that this represents more w represents length of the string, and when we pick this string, we say that the length of this string should be less than it should be greater than equal to n. This is the first condition when we choose w. Suppose we have ab, abc, abcd. This is my language, and then from this, if I say n, value of n is 3, number of states are 3, then w should be at least abc, or we can say w can be chosen as a, b, b, c, d, because it says here it says n is equal to 3 length, and it is satisfying the condition. Here the value of length of w is 5, which this 5 is greater than this number of states value, that is 3. So this is how we choose the w value. So once this is chosen, which we have chosen, in the next step, to prove that a language is not regular, we divide this w into three parts, that is x, y, and z part. And here we say y raised to power I. Now x is any part of the w part, means any number of characters. Similarly z, a few characters from that string. And what does it mean by y? Here basically here y is also a number of characters, but here it means that simply we say y I is pumping string, means this string will be repeated multi times, it will be generated multiple times. Now suppose I have example of a b c d b. This is my string, and from a language. So from this, if I choose this as this a as x and bb as y, and the remaining part as z, it means here I have considered the value of y as bb. So this is my pumping string. It will be generated multiple times with the value of yi, which means if I is equal to 0, y raised to power 0, there is no existence string with length 0. And if y is equal raised to power 1, then it means I am taking bb. Y raised to power 2 means bb bb. Y raised to power 3 means bb bb, three occurrences of this substring. So this is how we consider yi, that is the pumping string which is repeated multiple times. So when we consider this value, this division, then we should take care of few conditions x, y, I, z. Here firstly we have already considered that the length of w should be greater than equal to n, that is length of string should be greater than equal to number of states in pumping machine, and this is divided as xyz. And while dividing this, we have to check the conditions that the xy, that is both x and y together, has length which should be less than equal to this n. Similarly, there is another condition that y should not be 0, that is it should be greater than 0. It can be 1 2 3 4 and so on, but it should not be 0. This is the condition when we pick uh, this value from xyz. Again, if I consider the same example, then it means if x is equal to a over here, and this is yi, this is z, then it means when I is taken as 0, then my string will become only acb. If I is taken as 1, then means existence of y should be 1 only, so I will get a b b c b. And if I is equal to 2, then the string is something like this, two recurrences of this y value, that is bb and cb. This was z and this was x, so on it will keep on going. So this is, we divide it into three parts, and then based on this we will check whatever string is generated, whether that string belongs to a particular language or not. If it is a part of language, then it is considered as regular string. If it is not regular, then it doesn't belong to language, we say the this string is, this language is not regular. So here we have proved with the contradiction that the language is not regular. So this is how pumping lemma works for proving that a string is not regular. And in the next video we are going to discuss two examples of pumping lemma, so that we should have a good understanding of that. So thanks for watching the video.